Okay, we're in the middle of talking about integrals. Integral a to b of f of x dx. What we're going to do today is we are going to, so we've been talking much about indefinite integrals thus far. We are going to show the connection between substitution and definite integrals. And that that happens in this way. What we do is we say that the integral from a to b of f of x dx, if you were to do the integral of f of u du, then things change. The bounds change. And the bounds change to this, u of a and u of b. Right now, most of you don't understand what that means, and that's okay. I'm going to show you what it means in just a second. Are you ready? Okay, we're going to try to evaluate the integral from 0 to 2 of x times x squared plus 3 to the 4th power dx. Now, the challenge for you is to sometimes try to figure out when do I just do normal antiderivative and when do I use substitution. And anytime you have a product like this, that's a pretty good indication that you're going to have to use substitution. So if you look at it and you're like, oh, if I were to take the derivative, I'd have to use the chain rule or the quotient rule or the product rule. Or if you see that chain rule piece, it's a really good indication that substitution might be required. I can't tell you always the one way to do it. But in this situation, you guys are pretty good with it. You know that u is equal to what? X squared plus 3. So du is 2x dx. I don't have a 2x dx. 1/2 du is equal to x dx. Great. So I have 1/2 integral what? U to the 4th du. Pause. See how easy that was? When we started out the other day, we were going at snail's pace, weren't we? But the fact is that now you guys get it. You've done your practice. I feel like you're confident. But what changes in this situation is that we could kind of take a shortcut at this point. You guys like shortcuts, don't you? Okay. So here's just a little bit of a shortcut. And this is an embarrassing point for me. It really is. When I get to the anybody want to guess how I come up with the new bounds? Yeah. 0 squared plus 3 is 3. 2 squared is 4 plus 3 is 7. We good? What's the antiderivative? So it'll be u to the 10th over 10, right? When I multiply by the 1, or I'm sorry. Sorry. U to the 5th over 10, right? Okay. Now here's the deal. You guys are always used to plugging the x's back in, right? You don't have to. Just use 7 and 3. Those are for you. So yesterday we always plugged the x squared plus 3 back in, right? If you plug the x squared plus 3 back in, then instead of using 7 and 3, you would use 0 and 2. But since I have u, I'm going to use 7 and 3. So we plug in 7. We get 7 to the 5th over 10 minus 3 to the 5th over 10. No. So I don't want to figure, it's a really big number. Who cares? But you can just plug in your calculator, right? So do you see that we don't have to plug in the x? All right, let's try next one. Actually, they would accept this on the AP exam. Yeah, so you could do it like this, or you could do x squared plus 3 over 10 to the 5th power, and what you would do is you evaluate it 0 and 2. And look what happens. You end up with 2 squared is plus 3 is. So you end up with the same thing, right? Everybody see that? But I'm going to ask that you show the substitution piece on the test. Question. We did. That's how we got the 10 on the bottom. Because u to the 5th over 5 multiplied by 1/2 is u to the 5th over 10. Question. So just, you know, I won't give you one that ends up being some ridiculous number. But, you know, give me a fracture and decimal. But, yeah, if you want to multiply that out. Every year I mean to go back and change that problem. I always forget to. Okay, one more. Then you got your worksheet. A lot of time to work today. What's u? Why isn't it cosine of x? You get negative sine, and you got a sine to the 3rd, right? So if u is sine, I get the cosine. That's going to be a good deal. So du is equal to cosine of x dx. That was sweet, huh? That's just gone. So I have the integral from, yep, u to the 3rd du. And I've got to come up with my bounds now. So I plug in 0. What's the sign of 0? 0. What's the sign of pi over 2? 1. And I derive u to the 3rd. Kind of cool, huh? Tamara? Good. Thank you for asking. When I determine the bounds, I take 0 and I plug it in. The sign of 0 is 0, so that goes there. Then I plug in pi over 2. The sign of pi over 2 is 1, so that becomes 1. We good now? Okay, you got your worksheet.